Today, we shall discuss about Leontief's input-output model. Leontief's input-output model is a tool. It is a tool for analyzing intersectoral dependencies in the economy. Economy का मतलब एक country या region में the process और system जिससे goods and services बनते हैं और बिकते हैं, ये economy है. और intersectoral dependency मतलब the collaboration between two or more sectors. जैसे education sector, health sector, food sector, shelter sector. ये sectors interdependent है, मतलब एक दूसरे पर निर्भर करते हैं. एक example, जैसे food industry. ये farming service industries, producer sector industries, processor sector industries, and marketer sector industries पर depend करता है. Production मतलब producing the food. Manufacturing and processing मतलब treating the food. Turning fresh food into food products, like wheat grain to wheat flour or even ready-to-eat food like chapatis, rotis, etc. Marketing मतलब advertising the food. Distribution मतलब getting the food to the consumer. Not only consumer, food is distributed to all these sectors, which we have discussed above, and also by itself, as they also depend on food. So, in all these industries, the outputs are used by other industries and also by itself. Leontief's model is used to assess the total economic impact associated with a change in industry output or a change in the demand for one or more commodities. They are useful in planning the production levels in various industries necessary to meet given consumption goals and in analyzing the effects throughout the economy of changes in certain components. It can be used by governments to analyze economies and make informed policy decisions. Now, we shall understand this in detail by representing it in tabular form. The industries discussed, we can represent as I1, I2, I3, In. These industries are also consumers of it. In addition to it, households and government also consume it. We can call then final demand, and total of all of this is total output. Similarly, these represent production of industries I1, I2, In. Here, 4 is the units consumed by Industry 1 from the total production of Industry 1, 5 units are consumed by Industry 2 from the total production of Industry 1, and so on. Similarly, 8 unit is consumed by Industry 1 from the production of Industry 2, 7 unit is consumed by Industry 2 from the production of Industry 2, and so on. Now, for computation purpose, it is arranged matrix form. First, let's understand this representation. This is consumption and production of two industries 1 and 2. Total output of Industry 1 is 9, total output of Industry 2 is 14. For further computation, we have to calculate input-out coefficient. Input-output coefficient, also known as technology matrix, is number of units required from other industries to produce 1 unit of output. For example, 4 units are divided by total output 9. To get 1 unit similar 5 is divided by 14, 6 is divided by 9, and 8 is divided by 14. For clear understanding, we can calculate it column-wise, that is, units in first column is divided by total output of first row, and units in second column is divided by total output of second row. Thus, these are values per unit. This is represented in matrix form for further computation. We can understand the production and consumption from such tables. Now, let X is equal to total output, A is equal to consumption per unit, therefore, AX is equal to total unit, D is equal to the final demand, then AX plus D is equal to X, AX minus X is equal to D, X, A minus 1 is equal to D. X, A minus 1 is equal to D. D is equal to X, 1 minus A. X is equal to D divided by 1 minus A. Value of unit matrix I is 1, so we can write I instead on 1 and we get D, I minus A, inverse. I minus A Leontief's matrix. I minus A, inverse is Leontief's inverse. Hawkins-Simon condition for system to be viable. A, determinant of I minus A should be greater than 0, which means it needs to be positive. B, elements in the main diagonal should be positive. Let's see some examples. Example 1. The technology of an economic system of two industries is this. Test whether the system is viable as per Hawkins-Simon conditions. Solutions. A is this. I unit matrix minus A is equal to this. Subtracting we get 1 minus O.8 is 0.2. 0 minus 0.2 is minus 0.2. 0 minus 0.9 is minus 0.9. 1 minus 0.7 is 0.3. Determinant of I minus A is 0.2, 0.3, minus 0.2, minus 0.9. Is equal to 0.06 minus 0.18, is equal to minus 0.12 is less than 0. It is negative. Hence Hawkins-Simon conditions are not satisfied. Therefore, the given system is not viable. Example 2. The following inter-industry transaction table was constructed for an economy. Construct technology coefficient matrix showing direct requirement. Does a solution exist for this system? Solution. Technology matrix or coefficient matrix is number of units required from other industries to produce one unit of output. To get technology matrix coefficient matrix, units in first column is divided by total output of first row, and units in second column is divided by total output of second row. Column 1 elements are divided by total output of row 1. 500 is divided by 2500, 1750 is divided by 2500. Similarly, column 2 elements are divided by total output of row 2. 1600 is divided by 8000. This 1600 is divided by 8000 and we get this technology coefficient. These are values per unit. This is represented in matrix form. To check the viability, that is, whether it has a solution or not, Hawkins-Simon conditions need to be satisfied. Determinant of I minus A should be greater than 0, which means it needs to be positive and elements in the main diagonal should be positive. Here, in I minus A, elements in the diagonal are positive and determinant of I minus A, that is product of these two minus product of these two. 0.64 minus 1.4 is 0.5, which is positive and Hawkins-Simon condition is satisfied. Hence this system is viable, has solution. Example 3. In an economy there are two industries, P1 and P2, and the following table gives the supply and demand position in crores of rupees. Find the outputs when the final demand changes to 35 for P1 and 42 for P2. Solution. First we need to construct technology matrix, which is number of units required from other industries to produce one unit of output. To get technology matrix, units in first column is divided by total output of first row, and units in second column is divided by total output of second row. Column 1 elements are divided by total output of row 1, 10 is divided by 50, 20 is divided by 50. Similarly, column 2 elements are divided by total output of row 2, 25 is divided by 60, 30 is divided by 60, and we get this technology coefficient. These are values per unit. This is represented in matrix form. Total output X is equal to I minus A, inverse multiplied by D. I minus A, subtracting these two we get this. The determinant of I minus A is 0.236. Here Hawkins-Simon conditions are satisfied, hence it has solutions. To get total output, we need to find I minus A inverse. I minus A inverse is adjoint matrix divided by determinant of I minus A. Adjoint matrix is transpose of cofactors. Shortcut to calculate transpose of cofactors is interchanging the elements in the main diagonal and changing the signs of elements in off diagonal. Like this. Substituting the values of adjoint matrix I minus A divided by determinant I minus A and value of D, that is final change in demand 35 and 42 for P1 and P2 respectively, in the equation to find total output X. And solving it we get output of P1 is 150 crores and P2 is 201 crores. Example 4. An economy consists of two sectors with input-output matrix AE. A. Decide whether this economy is productive or not. B. Compute the total output vector X if the final demand vector is 3, 7. C. Which sectors run at profit if the price vector is 4, 3? Solution. Given D and price vector, part A, whether this economy is productive or not. If determinant I minus A is greater than 0, then the economy is said to be productive. A is this. I minus A, subtracting A from I we get this matrix. I minus A inverse is transpose of its cofactors. Shortcut method to calculate transpose of C is interchanging the elements in the main diagonal and changing the signs of elements in the off the main diagonal. And we get this. Find the determinant of I minus A, subtract the products of elements in the diagonals, we get this 0.5 times 0.2 minus 0 times 0.5 is equal to 0.1, it is positive, therefore the economy is productive. Part B. Compute the total output vector X if the final demand vector 3, 7. Solution. Total output X is equal to D. I minus A, inverse, D is equal to given and I minus A, inverse we have computed above. Substituting the values and solving, we get X is equal to 15, 29. Part C. Which sectors run at profit if the price vector is 4, 3? P is 4, 3. P minus P times A is equal to P is 4, 3 and PA is 4, 3 multiplied by this matrix is equal to 4, 3 minus 4.7, 1.5 is equal to minus 0.7, 1.5. First sector runs at loss, 0.7 per unit. Second sector runs at profit, 1.5 per unit.